All right, so today we move on to chapter 8. Take a look at the problem of the day and pause the video and solve it for the error analysis problem. All right, so lesson 8.1, model inverse and direct variation. Believe it or not, we talked about direct variation. I want to say like chapter 2 or 3 before. So it's something you've seen before, and if you remember, I guess I can even write it up here. It's y equals ax. And that's direct variation. You might want to make a note of it. We took y equals a times x as a direct variation. So there's a slope or a constant a. There's no y-intercept or b. It's a simple formula. Well, how that compares to inverse this chapter, which makes sense because we've already spent a lot of time talking about inverse functions. Inverse variation, two variables x and y are related as, I'm going to add something here. Two variables x and y are related as this following, it might be hard to see this, so I'll actually draw it. This following function, y equals a over x, where a cannot equal 0. So instead of saying a times x for direct variation, inverse is y equals a divided by x. So that's the premise to our lesson here. Constant of variation, denoted by the letter a, y is said to vary inversely with x. So that's how I would read this. Y varies inversely with x. A is my constant. Sometimes we call it like a slope as well. So how does this fit into our lesson? Let's look at example 1. So whether x and y show direct variation, inverse variation, or neither. Now what I want you to do for each of these problems is to actually rearrange the formula getting it in y equals form. So for a, I have negative 3x on the left. I want to move it over to the right. I get y equals positive 3x now. Now, is that direct variation, inverse variation, or neither? Hopefully you see it's direct variation because of the fact that it's y equals 3 times x, so a times x form. All right. Now for the next one, it is not in y equals form. First step we want to do is, you see that y is in the denominator, it's being divided by y. Let's take a second and multiply both sides by y. I don't want it in the denominator here. From here, I'm going to get yx equals 3. Now, if you notice, we still didn't have y by itself. So in the next step, I want to divide by x because it's y times x, right? And they cancel out. So my final answer, like for rearranging it, is y equals 3 over x. Now, it's in y-intercept form. Is it a direct variation, inverse, or neither? Hopefully you see that it's inverse variation because of the fact that it's 3 divided by x. All right, let's look at letter C here. We're going to take the x, we want y by itself, so we're going to transpose the x to the other side. And when we do that, we get y equals negative x plus 5. And if you notice, this one's going to be neither. And the main reason why it's neither is there's that extra number here. It would almost look like direct variation, like a negative 1 times x, but because of the plus 5 at the end, it is neither. All right, so let's continue on with this. Examples 2 and 3, it's something that you've seen before in direct variation. We're just tacking on inverse to it. So let's read example 2. The variables x and y vary inversely, with y equals 15 when x equals 1/3. Write an equation that relates x and y, then find y when x equals negative 10. So they say inversely. So we know our formula. Actually, I might just write it here. Is y equals a over x. The formula, right? So they give me a y and they give me an x. So let's plug them in. So y equals 15 equals a over 1/3. So in order to find my a, I'm given a y and x, so I plug them in. Now we see the variable a is left over. We want to get a by itself. Because it's being divided by 1/3, there's no reciprocal involved here. We're multiplying the whole fraction by 1/3, both sides, I should say. Once again, that means these will cancel out. It's not reciprocal because there's a big division bar with the 1/3 underneath. Now, 15 times 1/3 is 15 over 3, or 15 over 3, which is 5. So my a equals 5. Now, sentence 1 got us to figure out what my a is. Now, I'm not finished because I want to replug it back in as an equation. All right, on a test, you're not going to get full credit if you just tell me a equals 5. It says write an equation that relates x and y. So we rewrite simply just plugging in my a variable, which is 5. So line 2 gives me my equation. This is my first real answer. Y equals 5 over x. All right. This is what I want to see. Now it says, for the last sentence, then find y when x equals -10. Do not skip the step that's boxed. Please make sure you don't. The last part, they give me a new number for x. So 5 divided by -10. It simplifies to -1/2. So here's my first answer, here's my second answer. Now, example 3. Does the data below show an inverse variation? If so, write a model that gives y as a function of x. So, just to give you a little heads up here, I might write this over here. I want to show you what I do for this. Direct, inverse. For a, if I manipulate the formula, I want to multiply. Oh, hold on one second, let me fix that actually. And actually, let me backtrack for 1 second here. I'm going to talk about inverse first. If I want to find out if the inverse is true, and I take care of this, I want to get a by itself. It's actually going to be y equals ax. So let me just start with inverse. I'll come back to direct in a second. How did I do that? Look at your equation up here. If I want to get a by itself, I'd multiply both sides by x. So for these problems, we're going to find out what each of them equals. So a sub 1 I do what? X times y, 2 times 18, which is 36. All right, let's try a sub 2. Four times 9, which also equals 36. All right, so far so good. The goal is to get the same number each time. So inverse, if I want to find it out, oh, you know what? I wrote that wrong. Sorry about that. Let me backtrack for a second. Please make sure you have this. I've been doing that the whole time, but I wrote it wrong. Sorry about that. I switched my letters around. I wasn't paying attention. A equals xy, because if I wanted to solve, and I will backtrack for a second here, if it's y equals a over x, if we want a by itself, we multiply both sides by x. All right, so that's how we got that. So I was doing it right. Just make sure, fix your work, and write a equals xy for me, please. All right. So let's keep going. A sub 4 equals 8 times 4.5. Then a sub 5. All right, so what do you notice? When we do inverse, we rearrange it to get a equals xy. Multiply each set together. You see that they all get the same number, right? So yes, this is an inverse. My formula is y equals a over x, right? So a now, if you look here, was 36 over x. So that's our final answer. If they do not all equal the same number, it is not an inverse variation. All right, here they did, so that was my a because we had 36 for all of them. All right, so that's how you test from a table. All right, so let's take a look at the next term. Joint variation occurs when a quantity varies directly with the product of two or more quantities. Joint variation here, write these two examples down. Z equals AXY, P equals AQRS. So now we have two or more quantities with a direct variation. So Z equals, the A is the constant like before, X times Y, that's two quantities. P equals AQRS, Q times R times S, that's three quantities. So let's set up this next one. The variable Z varies jointly with X and Y. Also, Z equals 60 when X equals -4 and Y equals 5. So we'll start there. So Z varies jointly with X and Y. So Z equals AXY. Always put the A for the constant. From here, they tell me what Z equals 60, right? They tell me X equals -4. Tell me Y equals 5. So let's solve algebraically. Once again, we're looking for that A. Now I know from here to solve, I divide both sides by -20. I get A to equal -3. So that's my first one here. Remember, that's not my final answer for the first part. I want you to rewrite it plugging A back in. So Z equals -3xy. That is my first answer, just like we did the inverse one before. Now the final part, find Z when X equals 7 and Y equals 2. So Z equals -3 from here times 7 times 2. -3 times 7 is -21. -21 times 2 is -42. So my second major answer is Z equals -42. All right. For the last example here, we're going to write an expression for the given relationship, talking about varies jointly. So R varies inversely with S. Inverse, I know, is a fraction. A varies inversely with S. And that's an R here. R equals A over S. So inverse we know is a fraction. All right. Now, varies jointly is all multiplication. So Z varies jointly. Every time I see the word varies or whatever, I put an equal sign. With X and the square root of Y, don't forget your A. First, it's a constant. X square root of Y. And then the last one here, P varies inversely. So P, put an equal sign. Inverse, I know, is a fraction with an A up top. And the cube of Q. So Q to the third power goes here. All right, that's it for the lesson. Take a look at your homework for tonight, problem of the day. Also, there's 4 problems I want you to complete just to give you one of each type.